Hi, Assalamualaikum and a very good evening to Professor Dr. Muhammad Ikmar Nizam and also my fellow friends. So today, me, Siti Hajjah Peti Maznat and my friend Wan Mardiana are going to present about hydropower. So, let's go and learn about hydropower. So what is actually hydropower? Hydropower, also known as hydroelectric power, which it is a form of renewable energy that harnesses the power of flowing or falling water to generate the electricity. The energy is generated by using a dam or diversion structure to alter the natural flow of a river or other body of water. There are many types of hydropower facilities. They are all powered by the kinetic energy of flowing water as it moves downstream. Hydropower utilizes turbine or generators to convert the kinetic energy into electricity, which is then fed into the electrical grid to power homes, business, and industries. Hydropower harnesses the energy of water moving from higher to lower elevation. It can be generated from reservoirs and rivers. Reservoir hydropower plants rely on stored water in a reservoir, while run-of-river hydropower plants harness energy from the available flow of the river. Hydropower reservoirs often have multiple uses, providing drinking water, water for irrigation, flood and drought control, navigation service, as well as energy supplies. Hydropower currently is the largest source of renewable energy in the electricity sector. It relies on generally stable rainfall patterns and can be negatively impacted by climate-induced droughts or changes to ecosystem which impact rainfall patterns. The infrastructure needed to create hydropower can also impact on ecosystem in adverse way. For this reason, many consider small-scale hydro a more environmentally friendly option and especially suitable for communities in remote locations. The history of hydropower dates back thousands of years. For example, the Greeks used water wheels to green wheat into flour more than 2,000 years ago. The evolution of the modern hydropower turbine began in the mid-1700 series when a French hydraulic and military engineer Bernard Forest de Belledor wrote Architecture Hydraulique. Many key developments in hydropower technology occurred during the first half of the 19th century, and most recently, the past century has seen a number of hydroelectric advancements that have helped hydropower become an integral part of the renewable energy mix in the United States.
Hydroelectric power plant size. Hydropower facilities come in a variety of sizes, from large power plants that serve a large number of users to small, even micro plants run by private citizens for their own energy needs or to sell to utilities. Large hydropower. Large hydropower plants are facilities that have a capacity of more than 30 megawatts (MW). Small hydropower. Small hydropower plants are projects that generate electricity between 100 kilowatts and 10 megawatts. Micro hydropower. A micro hydropower plant has a capacity of up to 100 kilowatts. A small or micro hydroelectric power system can produce enough electricity for a single home, farm, ranch, or village.
Hydropower plants are characterized by several key features and components that enable them to generate electricity from the energy of moving water. Here are the main characterizations of a hydropower plant. First, we start with the dam. Dam, a power hydropower plant, typically includes a dam, which is a structure built across a river or a water reservoir. The dam creates a large reservoir by impounding water, allowing for a controlled flow and accumulation of water. Next, intake structure. The intake structure is located near the base of the dam or at a specific point in the river. It includes gates or screens to regulate the flow of water into the plant. Next, penstock. The penstock is a large pipe or conduit that carries the water from the intake structure or reservoir to the turbine. The pressure of the water flow helps maximize the energy conversion efficiency. Next, turbine. The turbine is the primary component responsible for converting the energy of moving water into mechanical energy. It is typically located within a powerhouse and its blades are turned by the force of water flowing through it. Moving on to generator, the mechanical energy produced by the turbine is then used to drive a generator. The generator converts the mechanical energy into electrical energy through the principle of electromagnetic induction. Next, transmission system. The electrical energy generated by the hydropower plant is transmitted through a network of power line to reach consumer. Transformers are used to step up the voltage for efficient long-distance transmission. Next, trail race. After passing through the turbine, the water is discharged from the plant into a trail race, which is a canal or a river downstream. This ensures the continuity of the water flows and minimizes environmental impact. After that, control system. Hydropower plants have a sophisticated control system to regulate and monitor various parameters such as water flow, turbine, speed, voltage, and frequency. This system ensures safe and efficient operation of the plant. Next, environmental consideration. Hydropower plants have varying environmental impacts depending on their size and location. Environmental consideration include managing the ecosystem of the river, ensuring fish passage, minimizing the impact on wildlife habitats, and addressing downstream water availability. Next, reservoir and flood control. Hydropower plants with reservoir provide benefits beyond electricity generation. They can store water during periods of excess flow and release it during the periods of droughts, thus helping with flood control, irrigation, and water supply management. These are some of the key characterizations of a hydropower plant. Each plant can differ in design and scale, but the underlying principle remain constant in harnessing the power of water to generate clean and renewable energy.
Let's proceed to the next section, hydropower classifications. The first one is the impoundment. The impoundment is a hydropower facility that utilizes a dam as a reservoir to store river water. Water is released from the reservoir and flows through a turbine, which in turn spins it, activating the generator to produce electricity. This type of hydropower system is able to meet both the base load and peak load demands, as the water can be released anytime from the reservoir to meet changing electricity needs. The next type is the diversion. A diversion or a run-of-river is a hydropower that does not require the use of a dam. It makes use of the natural decline of the riverbed to produce electricity. Since there is no dam, there is a limited to no storage reservoir to store river water. Because of that, the run-of-river system is mainly useful for baseload capacity depending on the changes in river flow. Another type is the pumped storage hydropower, or a PSH. A PSH is a type of hydropower that works like a giant battery. In a PSH, water that is used to spin the turbine can be reused by pumping back the water to its initial reservoir. During high electricity demands, the water is released to the lower reservoir, and during low electricity demand, the water is pumped back from the lower reservoir to the upper reservoir for later use.
In 2021, hydropower generation decreased by 0.4% despite a step increase in capacity growth. The decrease was caused by droughts in several parts of the world. Nevertheless, hydro remains the largest renewable source of electricity, generating more than all other renewable technologies combined. Today, the 22.5 gigawatt Three Gorges hydroelectric power plant in Yishang, Hubei province, China, is the world's most biggest hydropower station. It is a conventional impoundment hydropower facility exploiting the water resource of the Yangtze River. The project is owned and operated by China Three Gorges Corporation, or CTGC, through its subsidiary China Yangtze Power. In our country Malaysia, located in the state of Sarawak in Malaysian Borneo, the Bakun hydroelectric plant is the largest in the country with an installed capacity of 2,400 MW. Owned and operated by Sarawak Energy since 2017, the Bakun power plant began generating electricity in 2011 and contributes to the Sarawak Corridor of Renewable Energy, or SCORE, which aims to transform Sarawak into an advanced industrialized state by the year 2030.
Next, properties. The properties of hydropower plant refer to the characteristics and attributes that define its operation and performance. Here are the main properties of a hydropower plant. Firstly, capacity. The capacity of a hydropower plant refers to the maximum amount of electrical power it can generate. It is typically measured in megawatt and depends on factors such as the size of the turbine, water flow rate, and height of the water drop. Second, efficiency. Efficiency is a crucial property of a hydropower plant and indicates how effectively it can convert the energy of moving water into electrical energy. Higher efficiency means a greater percentage of the available energy is converted. Hydropower plants generally have high efficiency, often exceeding 90%. Third, reliability. Hydropower plants are known for their high reliability as they can operate continuously, providing a stable and consistent source of electricity. They are not affected by factors like field ability or weather conditions, which can impact other renewable energy sources. Fourth, flexibility. Hydropower plants offer a high degree of flexibility in operation. They can respond quickly to changes in demand, providing power on demand by adjusting the flow of water through the turbines. This flexibility is beneficial for maintaining grid stability and meeting peak demand periods. Fifth, longevity. Hydropower plants are designed to have long operational lifespan, often exceeding 50 years. The main components such as dam, turbines, and generators are built to withstand the test of time with proper maintenance and breeding upgrades. 6. Energy storage. Hydropower plants with reservoirs provide a form of energy storage. Excess electricity generated during low demand periods can be used to pump water from a lower reservoir to a higher one. This stored water can be released later to generate electricity during peak demand, acting as a form of energy storage. 7. Environmental impact. The environmental impact of a hydropower plant depends on factors such as its size, location, and design. While hydropower is a renewable energy source, the construction of large dams can lead to ecological changes affecting fish, habitats, river ecosystem, and local communities. Careful consideration and mitigation measures are important to minimize environmental impacts. 8. Cost effectiveness. Hydropower plants can provide a cost-effectiveness source of electricity in areas with suitable water resources. Once the infrastructure is in place, the operational costs of hydropower plants are relatively low compared to fossil fuel power plants. 9. Grid integration. Hydropower plants can be seamlessly integrated into existing power grids. They can provide baseload power, which is the minimum level of electricity needed to meet constant demand, and also serve as a reliable backup during power outage or periods of high demands. Those properties make hydropower plants a valuable and versatile source of clean and renewable energy, contributing to energy sustainability and reducing greenhouse gas emission.
Despite being non-polluting, hydropower system does have environmental impacts, especially from the construction of the dam and the reservoir, plus the operation of the hydroelectricity generators. A dam that creates a reservoir may obstruct fish migration. The dam can also change natural water properties such as temperatures and water chemistry, river flow characteristics, and silt loads. All of these changes can affect the ecology and the physical characteristics of the river. These changes may have negative effects on native plants and on animals in and around the river. Reservoirs may cover important natural areas, agricultural land, or archaeological sites. A reservoir and the operation of the dam may also result in the relocation of people. Greenhouse gases such as carbon dioxide and methane form in natural aquatic systems and in human-made water storage reservoirs as a result of the aerobic and anaerobic decomposition of biomass in the water. Manufacturing the concrete and steel in hydropower dams requires equipment that may produce emissions. However, given the long operating lifetime of a hydropower plant from 50 years to 100 years, these emissions are offset by the emissions-free hydroelectricity.
This verse makes it clear that Allah has sent down water for use to benefit the mankind. Taking a human life, for instance, because cooking requires water, drinking, cleaning, energy production, irrigation for growing crops, and so forth. Humans' continued reliance on water and the advantages it provides are becoming more apparent, as can be seen in this cutting-edge modern period. The hydro system, which uses water to produce electricity, is a good example of the function that water plays in society. The system's operability can only be seen or understood in terms of the availability of water resources. The electricity produced by this system will be used to power a range of electrical appliances, enabling people to live better and more comfortably.